5 was sine and cosine, and I said it a couple of times last week, but I can't stress the importance of mastering this before we move on to 4-6. You can't do 4-6 without knowing sine and cosine because you build on it. So for each of them, we talked about you're going to find A, which is in front of it, right? That's going to tell you if it's positive, it's pointing up. So for sine, you start at 0, go up, down, up. And for cosine, you'd start at amplitude and go down, up, up. And then the absolute value of A is your amplitude. That's how high or low you go. The B is what's in front of the trig function, and the X, 2 pi over that gives you your period. We multiply that times 1/4, 1/2, and 3/4. And then the first initial point is 0, the last is the period. And then we looked for a phase shift, which means we're going to add or subtract whatever it is onto our key points. And then we talked about a vertical shift, which would shift our graphs up and down, and a reflection flips it upside down. So those are all the individual pieces of what you need to know. And the only difference between sine and cosine is the pattern that you take. So sine starts at 0, goes up, down, up, and cosine starts at the amplitude, down, up, up. That's the only difference. So with number 1, it says y equals -3 sine of 2 pi x. My A here is what? -3. So the negative is telling you that you're going to have to do what with this? Flip it upside down. So instead of my sine going like this, it's going to have to flip upside down and go like this. But the absolute value of -3 is what your amplitude is. So your amplitude is 3. And then the period comes from what's in between the sine and the x, which is 2 pi. So my period is 2 pi over 2 pi, which is just 1. And then hopefully we know what 1 times 1/4 times 1/2 and times 3/4 is. So you could do that. There we go. My first key point, 1/4, 1/2, and then 3/4. And then because there's no phase shift, the very first one is 0, and the last one is the period, which is 1. Everybody with me so far? All right, so then I would plot my key points, the first one being 0, then 1/4, then 1/2, then 3/4, and the last one being the period, which is 1. 1, 2, 3 is my amplitude, 1, 2, -3. And because it's negative, instead of starting at 0 and going up, I'm starting at 0 and going down, up, down. Questions on that one? All right, then I get 2. Y equals 2 cosine 2x. So now it's cosine, which tells you that your pattern starts up, goes down, and comes back up again. The A is 2. The absolute value of 2 is 2, so that's the amplitude as well. The B is 2, so the period is 2 pi over 2, which is pi. Pi times 1/4 times 1/2 and 3/4 gets me my middle 3 points. So pi over 4, pi over 2, 3 pi over 4. First one, there's no phase shift, so first one 0, and last one is pi. Plot your key points. 0, pi over 4, pi over 2, 3 pi over 4, and pi. Amplitude is 2. And this time it's cosine, so I start at the +2, work my way down, up. Questions on that one? All right, number 3, find the amplitude and the period of, and then graph y equals sine of x minus pi. So what's different from this than what was before? There's a phase shift this time, right? So once we find our key points, then we're going to have to shift everything over. Which direction are we shifting, right or left? Right. To the right, because that's a negative pi, right? So we're shifting everything over pi. So my A is 1, which means my amplitude is 1. This is going in the positive direction. My B is 1, which means my period is 2 pi. And we've done this a couple of times, but that's our standard period, right? So hopefully if you remember that if you multiply that times 1/4, it's pi over 2 times a half, it's pi, times 3/4, it's 3 pi over 2. And then at the beginning would originally be the 0, and at the end would be the 2 pi. But I know that if I set this equal to 0, I'd get x equals pi, and that's my phase shift. So the phase shift is 1 pi to the right. So to each of these, I am adding pi. Oops. I'll go back and do the denominator. So from here, I get pi. This would be 2 pi over 2. So 3 pi over 2. 2 pi. 2 pi over 2, so 5 pi over 2, and 3 pi. Yep. Sure. Got it fast. Everybody good up to that point? Okay, so then my key points don't start at 0 like they've been. The first one is that phase shift, which is pi. Then I get 3 pi over 2. Then I get 2 pi. Then I get 5 pi over 2. And then I get 3 pi. My amplitude is 1. And this is sine. So I'm starting at the 0. And then I'm going up to 1. And then I'm coming back down to 0, to -1, back up to 0. So this should match what we said at the beginning, which is a positive shift to the right pi unit. So it would be, everything would be shifted over to the right. Questions on that one? All right, and then the last one, find the amplitude, the period, and the phase shift, and graph y equals, and I'm going to add on to this, I'm going to say +1 because we haven't done a vertical shift yet, okay? So A is -2, which means that this cosine, instead of starting up and working its way down, is actually going to start down and work its way up and then back down again. The amplitude is still a +2 because amplitude is absolute value. There is 1 in between the cosine and the x, which means the period is 2 pi over 1, or 2 pi. And there's a phase shift because if I set this equal to 0, I get that the phase shift is -pi over 2, and then I just added on a vertical shift up 1. So if we're adding, it's shifted up. If we're subtracting, it's shifted down. All right, period is 2 pi. So again, if I multiply times 1/4, 1/2, and 3/4, I get those same 3 initial points. Pi over 2, pi, 3 pi over 2. My original 0 is 0, and my original ending point is 2 pi. But then to each of these, I am now subtracting pi over 2. So this is -pi over 2. The first point should always be the phase shift. This would be 0. 2 pi over 2 minus pi over 2 is pi over 2. This is 2 pi over 2, which is pi. And this becomes 4 pi, or no, sorry. This becomes 4 pi over 2, 3 pi over 2. This time I've got 1 to the left of your y-axis, so make sure you have that space. -pi over 2, 0, pi over 2, pi, and 3 pi over 2. The very last thing I'm going to do is the phase shift. So I'm going to draw it like normal, and then I'm going to come back and do the phase shift. So my amplitude is 2. I mean, not the phase shift, sorry, the vertical shift. Okay, so amplitude is 2, but it's negative, and it's a phase shift to the left pi over 2. So I'm going down, up, down, down. And that would be if it had just the phase shift, but not the vertical shift. So the vertical shift up 1 means each and every one of those points is literally getting pushed up 1 place. So my curve, the answer, is that one. I will give you, like, I'll take out the colored pencils for this test, so if you would rather, like, do the shift lightly and then go back over it dark, especially when we get into you're going to start to see the reciprocal curves, they are different. You have to build on this kind of curve. So that might help. If you want to do it really lightly and then erase it, that's fine too. Just make sure I can tell the distinction between what should have been your overall answer. Questions on any of the warm-up ones? Because again, if you can't get that, today's going to be super confusing. All right. So 4-6 is called graphs of other trig functions. What's left? If we've only done sine and cosine, what are the other trig functions? Tangent, cotangent, cosecant, and secant, right? So tangent and cotangent are completely different. The process is different, okay? But then secant and cosecant build upon sine and cosine. If you know how to do sine, you can get to cosecant, and if you know how to do cosine, you can get to secant. That's the good news, okay? So tangent looks like this. If you think about why this happens, okay, if I went around my circle and I looked here and I said this is 1, 0, this is 0, 1, this is -1, 0, and this is 0, -1, okay? We did sine and cosine based on the x and y, but what would tangent be? How do I get to tangent? Y over x. So what's the tangent at 0? What would be the tangent if it's 0 over 1? 0, yeah? That's where this comes from. What would be the tangent at pi over 2? Undefined, and that's where these asymptotes come from, okay? Back over here, we're back at 0, so that curve will start again over here. And then back down here, we're back at undefined, which means there's another asymptote. So at all the halves of your standard tangent function, it's undefined, and undefined means that there's an asymptote there. Okay, so these curves don't flow like sine and cosine. They start and stop because you have undefined. Nowhere around your circle is sine undefined or cosine undefined. So there's always going to be those asymptotes. So the period for tangent and cotangent is now pi instead of 2 pi. The same points repeat every half circle or every pi for tangent. So when we're finding tangent, it's when we're finding period for tangent, it's pi over b instead of 2 pi over b. And then the domain is all real numbers except for the odd multiples of pi over 2, because that's where all those asymptotes were on the original graph. The range is all real numbers because you're going from -infinity to positive infinity, whereas sine and cosine you're going -1 to +1. And the vertical asymptotes are where we just said are at the pi over 2. An x-intercept occurs midway between each pair of the asymptotes. So this point here is half the distance between those two asymptotes. So you can either add the two asymptotes, divide by 2 to find the average, or a lot of times you can spot it. Like if I'm going from 1.5 to 2.5, you know in between is 2. But you are going to have to locate that point. And then it's an odd function with origin symmetry. Whatever happens on the top right happens on the bottom left. And the points in the graph 1/4 and 3/4 the way between the consecutive asymptotes have y coordinates of -1 and 1 respectively. So that means that while this is the halfway point between here and here, this happens at 1/4 the way, and this happens at 3/4 the way. So halfway between the asymptotes is your intercept. Halfway between the intercept and the asymptote is your -1 and your +1. Or your amplitude, because obviously that's going to change. All right, so this is how we do it, and I separate out a little bit, okay? But number 1, you're going to find the consecutive asymptotes by finding an interval containing 1 period. How we do that is this. We're going to take whatever the bx minus c is, so if it's in the parentheses with the x, then I take that, and I set it equal to -pi over 2 and +pi over 2. Those are going to be your middle two asymptotes. And then I'm going from there, I'm going to subtract the period from the one on the left, and I'm going to add the period to the one on the right, and now you've got 4 asymptotes. I'm going to find the points halfway between those asymptotes, and that's my intercept. And then I'm going to find the 1/4 point and the 3/4 point, and that's where my amplitude is going to go. So midway between the asymptotes is your intercept. 1/4 the way and 3/4 the way is your -1 and your +1, or your amplitude, because obviously that's going to shift. So when you're doing tangent, I expect to see, and cotangent, 4 asymptotes and 3 curves. So it would look, you'd have an asymptote, an asymptote, an asymptote, an asymptote, and then curve, curve, curve. Tangent goes up to the right, down to the left. All right, grab the following equation. Y equals, and I'm going to make it positive. I think it's so, I don't know why I did negative to start with. That's super confusing. Just keep it positive for now. Positive tangent of 2x. So the very first thing, I'm going to take my bx minus c. So if there was parentheses, I'd take everything in the parentheses, but there's no c this time, right? But there is a bx, which is 2x. I'm going to set this equal to negative pi over 2 and positive pi over 2. And then solve for x. So I'd end up dividing both sides by 2. Dividing by 2, same thing as multiplying by a half. And I get x equals negative pi over 4 and positive pi over 4. These are going to be my middle 2 asymptotes. To find the next ones, I need the period. So if the sine and cosine member is 2 pi over b, what did we say tangent was? Just pi over b. So pi over b is pi over 2. From the one on the left, I'm going to subtract it. From the one on the right, I'm going to add it. So this becomes 2 pi over 4, negative 3 pi over 4. This becomes 2 pi over 4, positive 3 pi over 4. Now I've got 4 asymptotes. Two are negative and 2 are positive, so I'm going to make sure I give myself room. Negative 3 pi over 4 would be the smallest one. Negative pi over 4 would be next. Positive pi over 4 would be next. And 3 pi over 4 would be the 4th one. With me so far? So those are where my asymptotes go. You can draw them if you want. They are dashed lines. They are not solid lines. Now I've got to find my intercepts. So what's halfway between negative 3/4 and negative 1/4? And if you can't figure it out, you add them. And then divide by 2. So this would be negative 4 pi over 4 divided by 2, negative pi over 2. Yep. Okay, now I got to find the point halfway between negative pi over 4 and positive pi over 4. What's that? 0. And then we did the negative pi over 4 and the negative 3 pi over 4. The positive would be the same. This would be positive pi over 2. So those are my intercepts as long as there's no vertical shift, which right now there's not. Still with me? Yep.
Where did you get the pi over 2? Or is that just like standard?
No, it's the halfway between those two asymptotes. So if I did pi over 4 plus 3 pi over 4, I get 4 pi over 4, which is pi. Divide that by 2, and I get, but I did it with the negatives. That's why it's the same.
Could you just do like, wait, that's the same as like 2 pi over 4, which is between 1 and 2.
Yep. Yep. Everybody good so far? Now I got to find the quarter point and the 3/4 point. Okay, so I cut it in half, and then I got to cut those halves in half again. Does that make sense? So I have to find a point that is a quarter the way between here and here and here and here. So exact would be negative 3 pi over 4 plus negative pi over 2, and then divide that by 2. I'm finding the middle point between those 2 points. That's a quarter of the way in. This is 2 pi over 4, negative 5 pi over 4, divided by 2, so times a half. And that's negative 5 pi over 8. And then 3/4 of the way in would be halfway between the negative pi over 2 and the negative pi over 4. So add those and divide by 2. This becomes 2 pi over 4, negative 3 pi over 4. Over 2 is times a half, negative 3 pi over 8. Now that's the exact, all right? I'm not going to make you do that on the test. It will take you way too long to find all 6 of those points. Just eyeball it. Eyeball your quarter of the way in and your 3/4 of the way in. So there'd be a point here, there'd be a point here, there'd be a point here, there'd be a point here. The reason you need those points is that's where you have to mark your amplitude. So 1/4 of the way in on tangent goes negative amplitude. 3/4 of the way in goes positive amplitude. So the amplitude on this one is what? What's in front of tangent? 1, right? So I'm only going up to 1 and down to 1. So 1/4 of the way in, if it's tangent, it goes down, left, and up, right. 1/4 of the way in, I'd go to negative amplitude. 3/4 of the way in, I'd go to positive amplitude. And I repeat that process for each of these little groups. And then my curve, up to the right, down to the left. Oh, I didn't do the quarter one. Wait, sorry. I went to quarter the way. So each of these points could be exact. Like if you found the quarter point, it would be that point, comma, -1, and then the 3/4 point would be negative 3 pi over 8, and positive 1. So the way an amplitude impacts a tangent is it either stretches it vertically or shrinks it. If it said 3 tangent of 2 pi, is that what we had? Yeah. If 3 tangent of 2x, then instead of going to -1, I'd go all the way down to -3, and that would be my first point. And instead of stopping at +1, it would be +3. So it just stretches it vertically. There's not a huge difference. Like if you put that in a calculator, you almost wouldn't even see it because it's so narrow. And I'm good with the eyeballing. Eyeball the 1/4 of the way in and then 3/4 of the way in. Just make sure you mark those points with your amplitude because the amplitude will change. All right, so review the process of tangent. You set bx minus c equal negative pi over 2, positive pi over 2. Solve for x. From the first one, you're going to subtract the period, which is pi over b. From the second one, you're going to add the period again, pi over b. Plot those points. Those are your asymptotes. Find the point halfway between. Those should be exact. So I'm expecting you to take the 2 asymptotes, add them, divide by 2, find the exact point in the middle. Plot those 3. There should be 3 of them. Eyeball 1/4 of the way in at negative amplitude, 3/4 of the way in at positive amplitude. Plot those points for all 3 curves. And then tangent goes up, right, and down, left. So let's say that this initially had been a negative and I left it negative. What does that change on your curves? If I flip this upside down, it's pointing up left and down right. Does that make sense? All right, so process, identify your parts just like we did before. A, this time I added in the 2. So A is 2, which means that's your amplitude. The B is 1. There's nothing in between tangent and the x. So the period is pi over b, which in this case would be pi. 2, what's inside the parentheses, which is x minus pi over 2. I'm going to set that equal to negative pi over 2 and positive pi over 2. Solve for x, and that's where x equals 0 and x equals pi comes from. Then from the 1 on the left, I am subtracting the period. So subtract pi from 0, and I get negative pi. And then adding the period to the one on the right, and adding pi to pi, and I get x equals 2 pi. Everybody good so far? Those are your asymptotes. So those are the pink lines on this. Then I had to find the point halfway between. So halfway between negative pi and 0 is negative pi over 2. Halfway between 0 and pi is positive pi over 2. Halfway between pi and 2 pi is 3 pi over 2. There's no vertical shift, so that's where my intercepts are going. Then a quarter the way in between the asymptotes, I have to go to negative amplitude. So if amplitude is 2, I have to come down here to negative 2. 3/4 the way in, I have to go up to positive 2, and then repeat that process. A quarter the way negative 2, 3/4 positive 2, a quarter negative 2, 3/4 positive 2, and then connect your points to get your curves. How many of you got it right, or were on that track when I stopped you? Okay, good. Questions overall on tangent. So let's say there's a vertical shift on this, right? Let's say at the end of it, it said +3. What are you going to do? How does it change it? Just shift everything up 3. I would do exactly the same thing I just did. Find my intercepts the same way. And then after you find the quarter point and the 3/4 point, then shift everything up or down. It's going to be a lot easier to find that center point on the x-axis than it is going to be at 3. So I would do it just like we did, and then take everything and shift it up 1, 2, 3 places, and my curve would have been up here. Okay, your asymptotes are still in the same place. So the vertical shift would have to be a physical move. The phase shift these times get taken care of in this process. So you don't have to worry about shifting points later. That is your phase shift. It takes care of it when you set it equal to negative pi over 2 and positive pi over 2. All right, so the good thing is almost everything is exactly the same for cotangent. There are 2 differences, okay? The A is still the same spot, still same effect. The B is still the same spot. Period is still still pi over b for cotangent, okay? The difference is what you set your bx minus c equal to. Think about the difference between tangent and cotangent as you move around your circle. The tangents are undefined at the top and the bottom, but the cotangents are undefined at the 0 and the pi. So while we set tangent, whatever's in the parentheses, equal to negative pi over 2 and positive pi over 2, we set cotangent equal to 0 and to pi. You still find the next point the same way. Take the left one, subtract the period, the right one, add the period. And then the last difference, so there's really only like 2 differences between tangent and cotangent, God bless you, is that cotangent starts up left and falls right. So tangent and negative cotangent have the same pattern, different steps, but same pattern. And negative tangent and cotangent have the same pattern, up right and down left. No, up left, down right. So the only 2 differences are here. Notice that we set bx minus c equal to 0 and bx minus c equal to pi on cotangent. And then the second difference is that it points up to the left and down to the right instead of the reverse, that is tangent. Everything else is exactly the same. So again, I don't know why I do this. Make it positive. I think it's super confusing to start negative. So y equals cotangent of pi over 2x. What's the amplitude? The A is 1, so that's your amplitude. So that quarter point and that 3/4 point are just going to -1 and +1. What's the B? Pi over 2. So the period is pi over pi over 2. Keep, change, flip. And my period is 2. With me so far? Whatever follows that cotangent, whatever's attached to it here is your bx minus c. There's no c, but there is a b. So I set pi over 2x equal to 0. God bless you. and pi over 2x equal to pi. So cotangent is 0 and pi. Divide both sides by pi over 2. Cancels. 0 divided by anything is 0. Divide by pi over 2 is the same thing as multiplying by 2 over pi, and I get x equals 2. Those are your middle two asymptotes. From the one on the left, you're going to subtract the period, which is 2. From the one on the right, you're going to add the period. And I get x equals -2 and x equals +4. Remember, these are asymptotes, which means they're lines, which means they need the x equals when you're giving them to me as an answer, which you will. So then draw your curve. I got a -2, a 0, a 2, and a 4. That's where my asymptotes go. What would be halfway between -2 and 0? -1. What would be halfway between 0 and 2? Halfway between 2 and 4? 3. That's where my intercepts go. And then my amplitude is 1. So a quarter of the way in. This is cotangent, so reverse it. A quarter of the way in, you go up. 3/4 the way in, you go down. A quarter of the way in up, 3/4 down. A quarter of the way in up, 3/4 down. And again, if the amplitude was something other than 1, I would stretch these. So if it was like 5 cotangent, then instead of only going up to +1, I'd go all the way up to +5 and all the way down to -5 on those 1/4 and 3/4 points. And if there was a vertical shift, you would literally just shift all of your points up or down. If it had been negative, like my original one said, it would flip upside down. So it would point down, left, and upright, just like the tangent. Questions? All right, your A again was 1, which means that's your amplitude. That's how high up or how low you're going on those 1/4 and 3/4 points. The period is pi over b. B is 1, so it's pi. And then I took x minus pi, set it equal to 0, and set it equal to pi. Subtract or add the pi to both sides. I get x equals pi and x equals 2 pi. Those are the middle two asymptotes. From the one on the left, you're going to subtract the period, which is pi, and I get 0. From the one on the right, you're going to add pi, which is the period, and I get x equals 3 pi. Those are my 4 asymptotes, so I plotted those 4 and then drew the asymptotes through them. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. Halfway between 2 pi and 3 pi is 5 pi over 2. That's where your intercepts go, and then a quarter of the way in, you go to positive 1, and 3/4 of the way in, you go to negative 1, because this is cotangent. Again, if it was negative, it'd flip upside down, and if it was an amplitude of, let's say, like 2, then instead of going to positive 1, negative 1, I would have gone to 2 and negative 2. And if there was a vertical shift, if something was added after the function, like if it said plus 3 at the end, everything would be shifted up 3, or if it was minus 3, everything would be shifted down 3. Questions on tangent or cotangent?